In this video, we are going to be looking at operations with polynomials. I think we're doing mostly about factoring. So this is section R.4 in our textbook, and we're looking at factoring polynomials. The definition of a factor is like if you had a number like 12, for example, you could factor that number to two things that multiply to 12. So 3 times 4, for example, or 6 times 2. What we're doing is we're taking this number and we're breaking it down into two factors whose product is still the same number. I could maybe put a 12 times 1, but that doesn't really work, or I guess that's all the ones I have for 12. But these are these two numbers are two factors whose product is 12. So when we factor a polynomial, we're doing the opposite of multiplying, but we're looking for two or more factors whose product is the original question. Now, doing it with numbers is one thing, but doing it with letters and variables is another thing. So we'll lead you through a number of different types of factoring. The first one, I don't know if it's most important, but it's one that you want to do every time, or look for it anyway, is to look for a common factor. So I'm looking at these three terms here, and I'm looking for something that's common between all of them. You can probably see that 5 will divide evenly into each of those, and also they each have at least one x. So 5x would be my common factor. Then what I do when I factor this is I need to write it as a product of two or more things. So it'll be a product of this times something else that we typically put in brackets. Now here, what I put here is what I get from this when I divide each term by 5x. Really, if you wanted to, you could write that in. 5x cubed divided by the 5x. 15x squared divided by the 5x. Or 5x divided by the 5x. Typically, we don't write this, but this is what we're doing in our head. So if I simplify each of these in turn, this would be an x squared. Minus, this would be a 3x, and this one here would be a 1. So this here is the factorization of that. I've got it, so in this case here I have three things. So 1 times 5 times x squared minus x3 plus 1. So this times this times this, the product of all of those is that. And that's what we're doing when we're factoring. Maybe pause if you want and factor this one to see if you get the right answer. Okay, hopefully you've pressed play. I can take a 4 out, an x, and a y. If I take that out of the first one, I'm just left with an x. If I take it out of the second one, or I divide this by that, I come up with a 3 and a y. So that would be the factors of this one. So that's known as common factoring. Sometimes we do this thing called factoring by grouping. Typically, you can do factoring by grouping if you have 4 terms. For example, here there's 1, 2, 3, there's 4 terms. So when you factor by grouping, what you do is you just look at these first two and do a common factor. Then look at the next two and look for a common factor. Then see, once you've done that, if there's another common factor you can take out. So for this one, I could take a b squared out. I'd be left with b minus 1. With this one, I can take a 2 out. Notice I make sure I put that sign in there. Take a 2 out, I'm left with a b minus 1. And now what I have are two terms. Here's one term, and here's another term right there. Notice that in each of those terms, there's a b minus 1. So I could factor that out front. If I factor a b minus 1 out of this term here, I'm just left with a b squared. If I factor a b minus 1 out of this term, I'm left with a plus 2. So this would be the factorization of that. Press pause, try this one. Okay, hopefully you press play, so I could take a 10a, oh that's a 10, out of the first one, leaving me with a squared plus 5. And I can take a minus 15 out of the next one, leaving me with, if I divide this by minus 15, it gives me a positive a squared. Minus 75 divided by minus 15 is a positive 5. Now here's one term, here's another term. Each have an a squared plus 5. So I can factor that out front. And then if I take it out of here, I'm left with a 10a. If I take it out of here, I'm left with a minus 15. And so that would be my factorization of this one. One thing I just noticed with this one is that I could take a common factor out of that too. Maybe I should have taken a common factor out of the first one to begin with. But I could take a common factor out now. It'd be a common factor 5, and that would leave me with a 2a minus 3. So this would be the complete factorization of that. Typically, if I have a number like that, we put it out front. So I could write it as 5 times a squared plus 5 times 2a minus 3. So that's probably the answer they'd have in a book for you. So that's factoring by grouping. Now, if I have an expression that is of this form here, x squared plus bx plus c, or something x squared plus something x plus a number, if I see that, it's possible that that could have come, or that I could break that down or factor it into something of this form here. Now, if you look carefully at these things, and if you look at examples, it turns out that this last term is a product of P and Q. That's what they're saying here. And that this middle term, B, is a sum of P and Q. So when we look to factor something like this, typically what we're doing is we're looking for two numbers. So two numbers that multiply to 15 and two numbers that add to a positive 8. This one over here, I'm going to look for two numbers that multiply to a 20 and add to a negative 9. There should be a y there. Add to a negative 9. Okay, in this case here, numbers that multiply to 15 and add to 8. 3 times 5. 3 times 5 is 15. 3 plus 5 is 8. Those are my two numbers. So when I factor this, I can rewrite it as two brackets, just like we had right there, two brackets. Two brackets, I'm going to split this x into an x here and an x there. And then the 15 I'm going to split into a 3, a plus 3, and a plus 5. And I think that's the proper factorization of that. You can always check by foiling like we did in the last section. So x times x is x squared. X times 5 is plus 5x. 3 times x is plus 3x. I'm looking at that and knowing that that adds to 8x, so life is good. I'm smiling. And 3 times 5 is 15. Okay, this one here. Two numbers we multiply to 20. I've got a 9 there. It's got to be 4 and 5, right? 4 times 5 is 20, but 4 plus 5 is a positive 9, not a negative 9. And I have to watch the signs there. But maybe if I put both of these as negative. Negative 4 times negative 5 is still a positive 20. But negative 4 plus a negative 5 is a negative 9. So those are my numbers that I want to use. So I can put my two brackets, y there and a y there, and I'll have a minus 4 and a minus 5. Again, if you're not sure, it's a good idea to FOIL things out and check to make sure that you're correct. Here's a couple more that are similar to that you can try. This first one, notice I could factor a number out of those. So I'm going to factor 3 out to begin with, leaving me with x squared minus 7x minus 30. Okay, now I'm going to look for two numbers, let me write it up here, who multiply to a negative 30 and add to a negative 7. Add to a negative 7. 10 and 3, so like negative 10 and a positive 3. Those multiply to negative 30 and they add to a negative 7. Those are my numbers. So I put an x here, an x there, a minus 10 here, a plus 3, done. Now I'm probably making them look fairly easy. You do need to practice these quite a bit in order to get good at recognizing those numbers. Here's another. Notice that they messed us up a little bit, that they threw some y squareds in there. The only really difference that makes to the question is that I'm going to have an x here and an x here, but these y's, to get the y squared there and a y there, all I have to do is put one y there and a y there. Now I do the same thing as I've just been doing. What are two numbers that multiply to negative 24 and add to a negative 5? 8 and 3, so negative 8 and a positive 3, that'll give me a negative 24 if I multiply. And if I add, that gives me a negative 5. Those are my numbers. So minus 8 there, positive 3 there. Okay, you'll probably want to practice that factoring quite a bit because it's an important skill to use. Okay, now if I have a number out front there, then that complicates matters just a little bit. I can't use the exact thing that I was doing before. But we do have this thing called an AC method. Let me show you how that works. First, you want to factor out a common factor, like you usually do. And then you multiply that first coefficient by the last one. And then you do the same thing that we did. So we look for things that multiply to whatever that product is and add to whatever the middle term is. But then this is where it changes a little bit. You rewrite the middle term using those two numbers, and then you group factor. Might seem a little confusing there. Let's try one. So here I've got one. I can't factor anything out. So what I do is I go 3 times negative 8, so that's negative 24. So I want to find two numbers that multiply to negative 24 and add to a positive 10. So they add to a positive 10. Probably 12 and a negative 2. Those multiply to negative 24 and they add to a positive 10. So now I can't just throw those in brackets. What I do is I replace this 10x with this. So I rewrite it as 3x squared plus 12x minus 2x minus 8. Now group factor. So I look at this and I look at that. So out of the first I can take a 3 and an x, leaving me with an x plus 4. Out of this one I can take a negative 2, leaving me with an x plus 4. Fortunately those two are the same, so I bring that out front, factor it out, and I'm left with a 3x minus 2. Okay, hopefully that you're getting that. That's a review for you. That's tricky, that is splitting that into two things and then group factoring. Okay, let's try this one. Oh, I can factor y out. Let me factor y out first. Plus y minus 21. Now we'll do the same thing as I've been doing. Multiply 10 times that. Oh, great. Negative 210. So things that multiply to negative 210, and they add to a positive 1. Oh, great. What would that be? 15 times 16? No. 15 times 14. 15 times 14. What's that? 225 minus, yeah, that's right. 15 times 14. So it would be a positive 15 and a negative 14. So I'm going to replace that with those two. So I have a y, and then 10y squared plus 15y minus 14y minus 21. Now group factor. There's one group, there's a second group. So I'll leave that y out there. So this would be, I could factor a 5y out, leaving me with 2y plus 3. This one I could factor a negative 7 out, leaving me with a 2y plus 3. Right on. I like it when these numbers are the same. If they're not the same, you can't go any further. You'd be done. Okay, so now just to clean it up, the 2y plus 3, I can bring that out front, and the 5y minus 7 gets left in the second bracket. Okay, so that's factoring using the AC method. There's another one I guess you can practice that on your own if you want. Now, just a couple of specialty kinds of factoring things that you can do. One of them is called the difference of squares. And that is if you have something squared minus something squared, you can factor that so that you put whatever is squared into each slot, and then one's plus and one's minus. For example, if I have x squared minus 16 and I wanted to factor that, I know it can go into two brackets. I split the x into an x and an x. I split the 16 into whatever its perfect square is, and it'd be 4. So I put a 4 there and a 4 there. One's plus, one's minus, done. If you wanted to FOIL it out and check, you can, and you notice the middle two terms will cancel. Here's a couple. Maybe press pause and try these, and then press play. X plus 3, x minus 3. Doesn't matter what order you put those in. This one here, so I need to split things up. And I recognize it because there's just two terms. One term, two term, and it's a subtract. And if both of these things are squares, or things that you could split exactly in half, then it's a difference of squares. So I'd put a 5y there and a 5y there. Z to the fourth would split to z squared and a z squared. Notice that each of these things have to be identical. And then 1's plus, 1's minus. Okay. I don't know if you could do that with that one. Let's just try it. There's a common factor of 5. Take a 5 out. Take a 5 out of that, left with 1. Minus x squared y to the 6th. Here there's two terms, difference of squares. Yeah. So I can put my two brackets. 1 is a funny number because it's 1 times 1. So I could split 1 into 1 and 1. And then this one I would split into an xy cubed if I split that in half. And so it has to be the exact thing there. And then 1's plus, 1's minus. Difference of squares. Okay, I'm not going to look at these too much because they are just another rule that you have to remember. But I did want to look at these ones here. These ones are called a sum of cubes or a difference of cubes. I don't have you memorize these. I give you these on a test, but these are examples of sum of cubes and difference of cubes. So things that you could factor. And what you have to do is just follow the template that they have there. So for example, if I needed to factor this one, I'll just do this one. So x cubed minus 64, that's the same thing as x cubed minus 4 to the third. 4 times 4 times 4 is 64. So if I'm going to factor that, I'm going to use this line right there to sort of copy. So I'm going to put a bracket and a bracket and then a bracket and a big one. Okay, so in the first one, it's just an a and then an a squared. So this is going to be an x. This would be an x squared. Then this b, in our case here, is 4. So it would be x minus 4. Okay, so x squared plus, and then it's a times b. So x times 4 is 4x. And then over here it says b squared. My b thing is 4, so 4 squared would be a positive 16. So this would be the factorization of that difference of cubes. And sum of cubes, you do the same thing. You just have to make sure you follow the correct pattern. Okay, hopefully that gives you a bit of a review on factoring. Maybe try some questions and try as many as it needs to get so that you're comfortable with the factoring.